gagging for beer, and I'll be talking about config management for the better part of an hour, so sorry about that. So my name is Trond. I'm not going to try and make you pronounce my last name. I work for RiksTV in Norway. My background is, I guess, a lot of the same as a lot of you guys. You do a lot of automation on Windows, which means a lot of PowerShell. But I've kind of turned into a more like a dev type of role. So I'm sitting in the backend team right now. So my team is the guys who are making the backend APIs for our services. So what I'm doing right now is basically taking care of the infrastructure and also the architecture of our apps, so that we try and convince my engineers to write apps that are actually monitorable and automatable and all that. I don't expect any of you to have heard of RiksTV. It's a Norwegian TV distributor. We call ourselves, I guess, an aggregator on good days. But we basically have a truckload of customers who are either using our set-top box to watch TV, and we also have some mobile apps. We recently launched our Apple TV app, which is really taken off. So the challenge right now that we have is this. This is basically the data from our CDN. So it just shows that customers are moving from like traditional methods of viewing TV with an antenna or whatnot to IPTV-based streams in a large way. So this is this is January last year. So this is basically our growth in the last 18 months or so. We also have a challenge in that RiksTV's kind of background 5 years ago, there was no IT in RiksTV. It's just a bunch of sales guys who basically sold stuff. And then so things had to happen fast and maybe a bit too fast, which means that we are stuck with a platform that currently doesn't scale that well. And we also, like you see from the growth curve, so we're gonna at a point in the near future, we're gonna be in deep shit if we don't do something quite radical. So they hired me on basically, and they basically said, we want the cloud. And that's good. But what they really wanted was someone to kind of own the process of making sure that the architecture is scalable and automatable and basically modernize the platform, which it's a bit of a challenge. I've been there since May of last year, and we're still not really scalable. But we've done some good stuff. We've done some groundwork, and one of the things we've done to kind of prepare for this is config management. So why config management? I don't know. How many of you guys are like using Chef or Puppet or Ansible, DSC, something? Wow, so you know all this stuff that I'm good. Then we can just cut for beers. But I try to think about config management as replacing an unknown state with a known state. So config management allows you to have a known state that your infrastructure is in. So instead of allowing engineers with the best intentions to install stuff on servers, maybe reconfigure them, you do all that with a tool that's versioned, so that you move from a known state to another instead of just random items of configuration. Early in config management, we talked a lot about configuration drift, which was basically someone does something to a server, and then you apply config management, and then that server gets back into a known state. And I don't know if you guys agree, but to me it feels like we've stopped talking about configuration drifts, and I think that's for two reasons. The one reason is that we're all trying to move to a more immutable infrastructure. So if something doesn't work, kill it, right? So you don't troubleshoot, you try and replace these pets with cattle. And the other thing is that if you think about config management, it's it's a positive thing. And what I mean with that is that you, for example, you don't use config management to make sure that a bunch of Windows features aren't there. You use config management to ensure that the features needed are there, right? So if you're writing config management in this defensive way, where you try to ensure that a file doesn't exist on the file system or a feature isn't installed, then suddenly you have an impossible task, really. So I think this configuration drift thing is kind of moving away. But I still think that config management, even in an immutable infrastructure, plays a role. If not for the servers, then at least for your cloud resources. And we have ARM templates and all the stuff for that. So I'm not saying that Ansible is always the right choice if you're like in a super immutable infrastructure and kind of moved into that new world. But I think it's a good idea to kind of have seen the different config management tools. So especially for you guys using Chef and Puppet, there's some philosophical differences in the various tools that might be valuable to know about. But anyway, for us, our goal is to transition into an immutable model, and that requires us to do some changes in our apps themselves. We have some state on our application servers that we simply need to get rid of. We use MSMQ still, so that's like hell for everything modern. So that's something we need to get rid of. So we have a ways to go, and this talk as well is not about organization that's done everything right. We are just starting to do good stuff now. So it's not a success story yet. Maybe I'll come back next year and talk about the success story of RiksTV, but right now, we are 20% along our way into kind of revamping ourselves, I would say. That said, we chose to use Ansible for our config management and some of our provisioning stuff, and I'm going to talk a little bit about why. First, have anyone like worked with Ansible except for Peter, of course? Yeah, so there's some knowledge. That's good. So it's a config management and orchestration tool, and why I say that is you can use it for config management, but you don't have to. So you can be as declarative as you want, and that's one of the maybe differences if you compare Ansible with DSC and Chef and Puppet, is that Ansible allows you to be a little bit more free in what you want to do. If you just want to hammer away some PowerShell scripts, you can do that. If you want to have really stringent change tracking, you can do that as well. So it's up to you how you want to do it. So it's written in Python. Currently, it only runs on Linux because of some multi-threading stuff. There is a fork in the Ansible upstream that allows you to run on Windows in Python 3. You can run it on the subsystem for Linux. You can, yeah. You can use the subsystem for Linux to kind of fake your way around it. It's not agent-based, so when you talk to a Windows machine, it uses WinRM, and when you talk to Linux target nodes, it uses SSH normally to communicate. So there's no agent or anything to install. And if you've used older Ansible versions, you may have had problems with getting it set up with WinRM. But now on the newer versions, you can do Kerberos, and you can basically take a vanilla 2012 R2 VM and just point at it, and there's a decent chance that works. So the way a lot of people use Ansible just as a CLI tool on their workstation, just fire away random tasks at collections of servers. You can also use it as a server. So Ansible or Red Hat has a paid product called Ansible Tower, which gives you a REST API and like a portal GUI on top of Ansible that you can use. And they recently open sourced kind of the upstream version of that, which is called AWX, which allows you to kind of give your users a portal and say, start this job and do this thing and get some reporting and logging back, things like that. So just a walkthrough of the various Ansible constructs. A module in Ansible, if you are used to PowerShell, is almost like a PowerShell commandlet or an advanced function. But a module has some characteristics. It always reports change. So when you run a module, it either changes something on your target node or it doesn't, but that gets reported back. So it's a, call it a special PowerShell function. So a task is basically run this module against a group of nodes. An inventory is a organized selection of nodes. So since Ansible isn't agent-based, the target node needs to know which servers to talk to. And that knowledge is an inventory, basically. So an inventory can be a text file, it can be a JSON file. We use basically REST services that pulls data from both Azure and Amazon to kind of populate our inventories. And those are super simple to write. And as long as they output JSON in a documented way, then it's a valid inventory. So then you have a play, which is a collection of tasks. And then a playbook, which is a collection of plays. And then more recently, we didn't have roles until a couple of years ago, but roles allow you to kind of encapsulate all of this into some, into like a packaged artifact. So there is like an app store for roles as well. So say that you want to install Docker or Nginx or do something that there's a good chance other people also have needed to do. You can just pull down a role which has various qualities as all open source stuff has. But yeah, so you can kind of encapsulate a lot of that. And we use roles a lot at Xterra. So we have a role for setting up the FileBeat agent, and we have a role to set up IIS, which contains both a reference to that FileBeat agent role and all the stuff that we do when we customize how our logging works and our security hardening and all that things. And then lastly, you have host vars, or just variables. Ansible has a very powerful variable, or you can do a lot of stuff with variables in Ansible. When it talks to a node, it kind of gathers some information about that node, like its IP address and whatever. And you can extend that as well. So you can say, hey, I want you to list all the software that's installed, and then you can take action based on those variables that's already been gathered. So yeah. So this is the DSL. Ansible is by default YAML based. If you don't know YAML, it's comparable to JSON, but in a more human readable format, at least when you get used to it. You can also just use JSON with Ansible if you want to, I think I would recommend just taking the time to kind of get acquainted with YAML. And if you use VS Code, there's really good plugins that allow you to get rid of all the red squiggles. For example, if you use tabs instead of spaces, then that's a big no-no in YAML. So there are plugins that help you do that. So when we started using Ansible at Xterra, I basically had this large number of micro-ish services running on a fairly chaotic infrastructure at a hosting provider, so no cloud. And so the goal was, okay, what do we need to do from here? And we decided that the first we need to do is to know what we have. So we basically knew that we were going to have to reverse engineer basically 5 years of manual changes against that environment. So before we did that, we decided to kind of greenfield our Ansible implementation. So we put that on hold, and then we used Ansible for a completely greenfield project, which was an Elasticsearch implementation. And I think that was a smart move. We got our CI pipeline set up, some rudimentary testing, and we could kind of battle-proof our ideas a little bit against greenfield before we started on that bad beast of our app servers. So once we did that, there was there's also this component of organization buy-in. A lot of the developers in my org they'd never worked in an environment where they weren't allowed to like just do whatever needed to be done. So this concept of having to pull request a configuration change instead of just friggin' doing it was quite alien to them. So by implementing Elasticsearch just purely in Ansible and kind of showing the org that this works, it's repeatable and it's stable and we can reprovision servers as often as we want. It went a long way, I think, to kind of prove that the idea works even in such a even though it was fairly small scale. I think that helped a lot. So I have, so this is the Amazon AWS project, which Red Hat recently open sourced. So if you find yourself wanting to play with Ansible and feel the need for either a portal or a REST interface to talk to, then I would definitely recommend checking that out. The installation documentation is a bit mushy right now, but it's not too hard to get it up and running. So that's recommended. So this is we've been through a couple of iterations. I guess we're currently on like V2.5 in terms of how we organize stuff. But as we moved along, we created just roles for everything. So we have a role for Elasticsearch, obviously, and a role for Logstash. And so you create all of these roles, and we created a role for IIS, which went through a couple of iterations. And what we did in the start was that we basically said that each part of our infrastructure has its own like playbook, so it lives in its own like separate little Ansible folder. So if you wanted to kind of reenact that or kind of run that deployment, then you would just go into that folder and execute it. And we also used another open source project called Flansible to kind of give us a very simple REST interface on top of that. So that's fine, but it also meant that if, say, we did some changes against our IIS role, then I would have to be sure that we re-execute all of those like targets that we had defined. So that didn't really scale, and it was kind of error-prone. Another problem with that is that we had like basic CI set up, so you would check in code and it would we're a .NET shop, so we use NuGet packages. Although this is just files in a folder zipped up, we still use NuGet just to be in line with what the rest of the organization is doing. But we didn't have any like smarts. It was just a stream of versions really, which is not the best idea. So that's also something that we wanted to fix a little bit. So our V2, we basically rewrote everything. We kept our roles like they were, but the way we kind of add roles or implement them was completely changed. So we used a global structure for injecting variables. So the first thing you do when you run Ansible now is that the target server would go through this logic of picking variables. And those can be either in Git, and they can also be in a console KV store. So if we have variables that we need to dynamically change outside of Git, we'll add them to console, and then we have a separate function that picks them up from there. So the server will essentially roll through its entire kind of variable set, and then from there we'll figure out what should I look like, and then start adding roles to itself and execute them. So that allows us to basically basically run one playbook against an environment, and then know that once that's done, it's in the desired state. That can take a while though. So most of the time we use another Ansible function called filters and tags to specify kind of what we want it to run. But that it doesn't add any functionality, it just makes the implementation faster. So if, for example, a developer says, hey, that server is kind of, I don't think it's right, then I can use filtering against that server only to make sure that we kind of get into a known state as quickly as possible. And so we also switched to what I call the release candidate pattern. So we use Git version to tag our releases, and essentially it works by, it's the best way to explain it. So essentially, if you're on the master branch and you tag, that becomes a release, and we say that that's a tested release and it's good. If you do just a random build, or you're on a branch that isn't master, then that's a release candidate build. So we consider that good for our test environments, but not our production environment. So although we don't have as much automated testing around this as we'd like to, at least we have some qualifications in how we kind of release changes to the Ansible repos into production. So I can show that in a bit as well. Yeah, I can show a bunch of stuff actually. So this is essentially, can you guys see all right? It's a fairly small room, so I hope my dark theme isn't too bad on you. So this is basically our variable structure. So once the server kind of gets targeted by Ansible, it basically starts on the top and then moves its way down. And based on these server tags we have attached to servers, either in Azure or Amazon, it kind of runs through the right set of config files. So for instance, if I deploy a server to a web admin tag, then it gets these variables, and then it will get the dev variables. And then we have more and more specialized things. So it kind of overrides itself if there's conflicts. So that means that if I want to test out the newer console version against dev, that's one change in one file, and it kind of gets implemented for all our dev servers. So it's almost like group policy, I guess. You can be as, did I just say group policy? It's not always, but it kind of cascades down. So you can be as general or as specialized as you want to be. And then the next thing that happens is that it basically starts iterating on this long list of server roles that we have. And if the server has the right tags, it will get these, and if not, it'll just ignore them, which is, yeah.
When you say tags, do you mean Amazon or Azure?
So a tag as far as Ansible see it, a tag is just metadata around a target node. But since the variables, or since the inventory format is completely open, so yeah, we've built it so that Amazon EC2 tags and Azure tags get pulled in. Yeah.
Might be worth mentioning the dynamic inventory capabilities.
Yeah. So that's my point. I can actually show it to you. Our inventory is this. So when Ansible starts running against our dev environment, it runs this tiny file that just gets this back. And this is our live Amazon environment. And we have similar stuff for Azure as well, because we're kind of midway into migrating to EC2. So all of this stuff, you see here, RiksTV environment, that shows up as an Ansible tag. So that's something I can just test against inside my playbooks. Yeah. So the way we organize, and that's a decision we made early on as well, was that you can't rely on server names when you do mass configuration. You have to have some other structure. So we have this idea of a service family and a service group, and so a service family kind of indicates the general role of the server, such as common or logging or whatever. And then we have groups inside of there that tells us if the server is a Logstash node or an Elasticsearch node or whatever. So we have actually 3 levels that we can use to kind of indicate how service should be. So that gives us, so the names here are just, we do name servers. We have a little microservice that looks at the tags and names them accordingly, but it's just to give ourselves a bit friendlier names. It's not something we need really. And as you can see here on top, the dynamic inventory also supports grouping. So you can say that do this against all my domain controllers or just the domain controllers in Western Europe and whatever. So that's supported by the filtering functionality inside of Ansible as well. So it's as flexible as you want it to be. When you start out, most people just start by sticking server names in a text file, and that's completely fine for just testing it out. But obviously in a cloud world where nodes come and go, it's important to have a dynamic inventory. So this one for Amazon we wrote in Python, and I have one on GitHub that's for Azure, which is written in C#. So you can just stick that in Azure websites, and you have your dynamic inventory. I wouldn't call that code optimized though. Since what's that? Yeah, so this is a Flask app actually. It's just using the Boto libraries to talk to Amazon. Yeah, but it doesn't really matter. Like I said, as long as you are able to produce a JSON that kind of describes your environment, then you're good as far as Ansible is concerned. Yeah. So I thought I could maybe just run a couple of things. So I created a role inside of our temp namespace, which I just called WinOps, and right now there's one server there. So this site YAML I'm running, it's capable of implementing our entire configuration, but right now I'm limiting it to this group. So this is Ansible running. It's not terribly exciting. It just does a bunch of stuff. But it starts with looking at all those folders and figuring out which config files are for me, which variables should I kind of activate before starting to do stuff. And then it basically does role by role according to those variables. So we have this basic config Windows, which sets up stuff. And as you can see, as it runs now, it's just giving me a green OK, and that means that there is no change. And you'll see some things that are skipping because of variable conditions that I've set. And the yellow one is when Ansible finds a change, where it just executes, basically. So the next time I run this, hopefully that change will be a green, because we already did it. So there's as much change tracking as you want. And you can also use Ansible to just run a PowerShell script, and then obviously you don't have any change tracking unless you do some cheating, like create a text file and then you just check if that text file already exists and then skip it or something. So we use that like a last resource. If there's no other way to kind of get good change tracking, we'll just basically create a file in a folder to indicate that we've already run it. So yeah. So that's basically how Ansible runs, and it will go through its stages. And now after that basic config is done, you'll see it starts skipping a whole bunch of our infrastructure, which is basically because I haven't given it the roles that tells it to configure it that way. So yeah, we can let that run. So yeah, I was here, right? As far as testing goes, we check this into TeamCity. We do linting. So if you pull a request in YAML that's not valid, then we basically fail the build. And that's just some basic safeguards. There's also testing frameworks you can use for Ansible. Test Kitchen also has Ansible plugin, so you can use Test Kitchen, which is a chef tool really to test Ansible configs as well. Problem I found is that testing infra is slow, and we don't want to be slow. We want to be fast. So that's one of many, many things that we haven't cracked the code on just yet. And yeah, we're also the Ansible code itself now runs inside of Docker containers, which means that if I want to make sure that my config works with both Ansible 2.4 and 2.3 and whatever version, I can just use different Docker containers to kind of implement that. So we package a lot of bunch of stuff up into those containers and let them run. But then obviously you can also just do it on your computer like I'm doing. I would say that we are not halfway there, not even close, but we're making progress, and the fact that we now it took a while, but we kind of have a complete picture of how our environment looks. So we're able to reproduce every single server in our environment, and that was kind of a big deal because, yeah, like I said, there's five years of developers doing weird stuff to servers. Kind of, yeah, it's not good. And at the same time, you kind of have to respect a developer who they've always done stuff that way. So for me to come in and kind of to kind of enforce them to change their ways might not be so good. Another mistake that we did was basically the control plane. So I think we'd be better off if the first thing we did was to give our devs a good portal experience to implement or to execute changes. So right now, or it's been the situation has been that we expect developers to implement their changes in Ansible code, but we haven't given them a good control plane to execute those changes because it takes a little bit of expert knowledge. So that's stuff we're fixing now. We haven't quite decided if we should go with Ansible Tower or AWS or some other custom thing that I'm working on, which I can talk more about if we have time at the end. But that's, yeah, I would definitely not underestimate it if I do it again. But we have some breakthrough. This is the first pull request from a developer to kind of do some change in Ansible. So this is, yeah, some new microservice thingy. And he just figured out that, hey, if I just copy whatever's above this block of code and just make a few changes, then good things will happen and I don't have to log into the server. So that was kind of like that was a little victory for us. So that's kind of improving throughout the organization. And I don't expect developers to build advanced stuff, but stuff like this, when they just have a new service or a new IIS folder or something, the fact that they can themselves just pull requests in is really good. I think it shows we're on the right path. And then also this tooling enables tooling, and a couple of examples of that is that we decided to implement Consul, which is a service discovery KV store, which again requires you to have an agent on all your servers. We're also implementing FileBeat as part of our Elasticsearch implementation, and the fact that we can just rapidly provision out these agents with config that might change, or we might come up with something better. That's really powerful. So what we're seeing is that these projects where before the implementation took super long, right now we can just iterate a couple of times in dev and then just push the entire thing to production. So it's really quick for us to kind of implement these helper tools like FileBeat and Consul and whatnot. So that's been really good. So our next steps are to move from manage to provision. And what I mean with that is that we plan to take all the code that we now have to describe our environment, and instead of doing it after the fact, we'll be using that to actually build images instead. So we use Packer already to generate EC2 images, and Packer has a really good Ansible plugin. So basically all the stuff you take, you can basically start to kind of shift your config left and move it into the provisioning phase instead of the management phase as you kind of modernize your stack. So that's something we plan to do. And with that, we'll be able to break apart these infrastructure monoliths that's been living for far too long in our environment. So I think config management is here to stay, although it's not considered super modern anymore. I think whether you're running really like light immutable infra or not, there's always going to be infrastructure or configuration that needs to be managed. We use the same like Ansible stuff for provisioning EC2 resources as we do for managing IIS. So I think there's always going to be a requirement to manage. If you are a complete like Amazon Lambda only shop, Ansible is likely not the best tool. I would probably do more in regards to maybe Terraform or more of those cloud only tools. And one big thing for us is that we're moving into what I call event-driven config management. So I want to make sure that when a developer pushes a button, there's no way we can bring down services based on that. So we have already working services that kind of take a group of servers and figures out which sequence they should be managed in to make sure that we always stay up. So that's also something we're feeding into the Docker containers that run them. So we have this, we use Amazon queues and Kubernetes basically to kind of sequentially apply configuration to kind of give us a safety valve for how we implement changes to our org. I got the 5-minute mark just minutes ago, so that means I'm on 4 minutes now. But I guess I can, let's just see how my config is doing. It's done. So before you guys start firing questions at me, Peter, this is basically my little test node skipping most of the config because I didn't want it to. I have some more demos, so if you guys want to geek out with Ansible afterwards and see more stuff, then just let me know and I can show more of kind of the details and nitty-gritty parts of it. But yeah, I don't know if there's any questions around. There's one there at least.
Really super quick question. You've got a step there saying reboot system after
yeah.
Something. How does Ansible handle that? Because we're using Chef and Chef doesn't handle that very well.
So in newer versions of Ansible, there's a built-in thing. So what before that was part of Ansible, there was actually a role in the Ansible Galaxy, the app store I talked about, from yours truly called Windows Reboot, and it's the sexiest role. Now, so what it does, since you have a control node, basically the node that kind of orchestrates the implementation, what we do is that we tell WinRM to reboot, and then we test the WinRM endpoint until it comes back up, and then we continue on. So and especially on Windows, as you probably know, reboots are like, it's part of it. So what we have this global variable which is called allow reboot, which is set to false in prod and true in dev. And so we basically ask that if we are okay to reboot if it's required. If it's false, then we basically stop the playbook and say, hey, this requires manual intervention. But in dev, we'll just reboot. And if someone uses that service right then that's too bad.
Cool, thank you.
There's one over here as well, yeah. Sorry, I didn't stand on this side of the room at all, but I'll do it now.
What is the scale of the implementation right now or in full capacity? And did you see any problems in the current scale?
You mean the scale of our environment,
yeah,
or the Ansible implementation?
Both. What is the full capacity that you will want to put Ansible on or use Ansible on?
So the number of target nodes, around 100, I think. But like I said, we have some monoliths that we have to start breaking apart. But there's some like supporting stuff, Elasticsearch clusters stuff, Kubernetes. Yeah, I mean, probably, I don't know, 100, 120 across all environments.
Do you see any problems in growing from 5 nodes, 15 nodes?
No, I mean, Ansible is as parallel as you want. So by default, I think Ansible does 5 and 5 nodes. So if I had 10 here, you would see it like send a command to 5, wait for all of them to complete, and then do 5 more. But you can configure that. But as I touched on towards the end, the way we're kind of moving into event-based infra probably means that each like Ansible Docker container will only manage one or a few servers at a time, and then kill itself, and then another container will do the rest. So it's slower, but it gives us a lot more control to make sure that we don't like bring down an entire set of API servers or whatever. Yeah.
Back 1 second.
So we have a large on-premise estate. You mentioned getting stuff from AWS and from Azure.
Yeah.
Does it have the same detecting capabilities for an on-premise
So
estate?
if you run Tower, I know it has plugins for like VMware vCenter, but honestly, with a little bit of PowerShell scripting, you're able to produce that stuff. I created one for VMM in a couple of hours. So you just have to, like, what you need is to basically report your nodes' names, IP addresses, and then figure out some kind of tagging scheme. So with a little bit of PowerShell or whatever language you want, that's easy to do. And you'll also find some helper scripts in the Ansible repo, which I haven't looked at in a while, but yeah.
There are some dynamic inventory things out of the box for
Yeah, yeah. So the reason why we write our own is that we kind of use those tags in a kind of a weird way. So it gives us a little bit more control. So I'm able to, depending on the prefix of the tag, I can choose whether that's forwarded into Ansible or not. So it's just us being weird, really. Yeah. Any more? I think we have time for yeah.
A culture question rather than a technology question. So you mentioned that you've introduced this and you were really pleased when a dev checked in a config change.
Yeah.
How have you found that change? Have you encouraged the devs to take ownership of the config connected to their code? Or do you still manage that in the ops space? I'm just curious to how you're dealing with that shift of responsibility.
It's a tough problem. I think I don't want to be like the bastard operator from hell, which I feel it inside me that I have the tendency. So I try and make sure that I'm not. So I want to provide devs with tools that make them want to do it this way and not the old way. So it's been slow, but I think, like I said, to start with a greenfield app that kind of shows them the power of the system, the fact that we could like refresh our entire Elasticsearch cluster in a day without touching it at all. So we try and like share these success stories, and I think that's the way to go, so that devs kind of know that it's there and it's good for everyone to use it, and just be super helpful. And I mean, I have devs who actually don't know how to log off a server, especially on 22, because there's no start button. So I just want to set the bar like super duper low and like I want to be the helpful dude and not the bastard dude. But obvious that at some point we'll just, when everything's immutable, then you are in a kind of different space. But right now we're trying to do the soft, slow thing. Yeah. Peter.
When's the last time it made you cry?
I cry on a daily basis. No, I mean, I think, and Jeffrey Snover touched on this, a talk he gave years ago, that in order to understand what a person does, you have to understand his or her motivations. And I mean, our developers are under tremendous stress, and what they want to do is close user stories. That's what they care about. They don't care about this config shit. And I can't really kind of expect them to feel a lot of emotions about it. And once you kind of understand that, you kind of understand why they do what they want to do. So if that server isn't configured correctly, the shortest path for a developer is to log on and just fix shit. And you kind of have to understand that in order to, you kind of have to play on their team in a way. So yeah, but cry, yeah, I both cry and bang my head way, way often, which is why I'm growing bald. Unlike some of the other in the audience. Yeah.
Were there any features of Ansible over other options that made it particularly appealing for managing Windows?
For managing Windows, I don't know. I mean, I've been part of the Ansible community for a long time, and I think it has that strong variable support is really important to us. And the fact that you have a control node that can orchestrate instead of each target node just being self-aware but know nothing against the rest of the environment. Actually, I have
the agentless nature of it seems very appealing to me, since we already have firewalls set up for the WinRM ports and so on.
Yeah. So this is an example of the power of agentless. The fact that this is our Kubernetes provisioning, so it's not related at all. But the fact that I can delegate to, so I can say, hey, on behalf of this app server, create an account in the domain controller or talk to the load balancer, all in the context of another server. You can't do that without like a central control node. So that's really, really powerful. So here we, I think for each Kubernetes worker, we do some stuff on a certificate authority server, something. I can't really remember. But that's an example of the flexibility you get in Ansible. That's really...
I've got an answer for that as well. I was able to get something useful in production within a day in a hackathon. It's the thing I found the most compelling about it.
So architecturally,
I just couldn't get started with quickly enough by comparison.
yeah. So the architecture makes it
Really
suitable for that.
hackable.
Yeah.
Yeah.
And it's also, for example, if you need to write a module that doesn't exist yet, then you can own that in your own code base and iterate on it, and then contribute it back really easily.
Yeah, and you don't even have to contribute it back. You can just use like a mix of the official ones. And tomorrow, I don't know if you guys are going to the PowerShell day tomorrow, but I'm looking more into like how does this stuff work and how can you write PowerShell that Ansible can use, and a little bit of DSC and Ansible as well. So if you guys are going to that, then I'm kind of continuing on. It's like a series of. But yeah, so if you want to learn more, then please come along to that. Should be good fun. I guess we're more than over time, yeah? And there's beers.
Yes.
Let's go drink. Thank you so much.
One last.